What do the water in a fountain, a human cannonball, or even American ball thrown like this all have in common? Mathematically, they follow a parabolic path, which is the path followed by a projectile. But wait a second, what is a projectile motion? A projectile motion is when any object or particle that once projected or dropped continues in motion by its own inertia and is only influenced by the gravity. We will also consider a resistance as a negligible. Projectile motion has two components, vertical and horizontal. Let's take an example. If we throw the ball upward, it will go upward and then simply downward. And if it's simply being dropped, it will go downward. These two examples are not examples of projectile motion. Projectile motion needs to be followed by a parabolic path, followed by initial velocity. In another word, it will start moving either horizontally or at an angle. As the ball here starts its journey, the ball will experience two different independent velocities. As you can see, the ball begins with a horizontal velocity of 15 meters per second and 20 meters per second for vertical velocity. As the ball starts its journey, the velocity of horizontal is constant. However, for the vertical, its velocity decreased by 10 meters per second. As the ball reaches its maximum height, the vertical velocity is 0, while the horizontal didn't change as I said before. As the ball starts to move downward, the vertical velocity starts to increase but in the opposite direction. The reason why the horizontal velocity is constant is due that it's not affected by the gravity. And vertical velocity is related to what Sir Isaac Newton said in describing freefall acceleration. However, the two components, horizontal and vertical, has no effect on each other, and when we solve any projectile problems, they are treated independently. I will show you how. Assume that you stand on a flat surface, holding two balls. One is thrown perfectly horizontal, while the other is thrown vertically downward, both at the same height. When the two balls are thrown, they will move downward towards the ground due to the gravity. If we assume that the air resistance is negligible and both start with the same vertical velocity, the two balls would reach the ground at the same exact time. The vertical component could be applied with the equations of motion with uniform acceleration, while the horizontal motion, due to its constant speed, it only applies the equation of speed equal velocity multiplied by the time. The two components has only one common factor, which is the time for the object's traveling. Make sure that you don't get confused between the horizontal velocity and displacement with those that apply to the vertical motion.